Hi, everybody. Welcome back. So, this week we're going to continue on with some set theory, and I have some new George Crumb music to show you and have you listen to, and some new concepts for us to get to. So, the first thing I'll do is just say I've got some place where I'm going to take notes for sure. I want to introduce you to this set of pieces. They're called the Macrocosmos that George Crumb composed relatively early in his career for piano. And there's two books, so he has 12 pieces that are about the zodiac, and some of them are not totally related to the zodiac. They're just things that I think he thought were cool. But anyway, it's all together called the Macrocosmos, and you can see like this one's Cancer, but it also has some other associations that he relates to it. And here's the Pisces. This is Taurus, but it's also called a pastoral from the kingdom of Atlantis circa 10,000 BC. I don't think he means for you to think about these things too literally. This is the one that we're going to focus on today, the Crucifixus movement that he calls, I don't know exactly why it associates with Capricorn. The Phantom Gondolier for Scorpio. Night Spell 1 for Sagittarius. I will link to the full set so that you can listen to it if you'd like. You can see as I'm going through here, he calls the Libra, the one he wrote for Libra, the Aeolian Harp, Music of Shadows. He calls for a lot of extended techniques, and a lot of times players are asked to reach inside the piano and strum the chords inside the piano on maybe with a piece of metal or maybe your fingers, or like it kind of depends. And these are pieces also where we have these big graphic scores, like the Crucifixus movement itself. But here's the Magic Circle of Infinity, which is for the Leo. And you can see these are a little bit elaborate. Most of the time I have seen performers play this without the score at all, like they've memorized all of it. And so then sometimes people ask, like, well, what was the point of the graphic score if they're not even going to look at it and like the audience can't see it? And I think that that's thinking about it just not quite the right way. I think that it's part of his complete expression that he wants the score to look a certain way, and lots of composers have those kinds of preferences. His are also just graphic in the sense that they are figures. They represent things. There's the Spiral Galaxy, which that page is upside down for some reason, but that one looks like Aquarius. And I guess it might not be upside down in the sense that you could start reading it from, well, no, you should start reading it from here, so never mind. There's two books of them, like I said. This is, over here is the, let's go back to the beginning of it. There. Second book. And you can see that these in general are really, what's the word? Intense. They're involved. They would take a lot to kind of prepare, more so than just sort of sitting down and sight reading it. They have quotations, like this one quotes the Agnus Dei. Notice that you can play it not just right to left, but you can also play it upside down. Partly because he expects you to have the score moving around in space as you play. I highly encourage you to listen to the whole thing. It's great. This is another movement I've spent some time with and we may end up talking about, but I think I want to just focus on the Crucifixus movement. So you'll notice that it's quite apparently shaped like a cross. He calls it Crucifixus, which is a word you might recognize if you've ever been in a choir that sang a Latin mass, like one of the many versions of the mass that had been set by our kind of esteemed classical composers. And Crucifixus often is a word that shows up in the credo movement of the mass, as opposed to the other movements, where the creed, as in like the Nicene Creed or the Apostles' Creed, you might be familiar with those, where it mentions the idea of Jesus being crucified. And so that word comes from that context. Here, you can see that this initial part actually shows up in a couple of other movements. So if you're listening to it, you might recognize that, like, oh, actually I heard that in an earlier part of the volume as well. It happens, I guess, mostly in volume 1, in the primeval sounds that begin the piece, and then again in number 9, which is the Abyss of Time. So these super low, what we'll call a series of triads here. So in order to talk about what is happening in these pieces, we need to get some more of our set theory vocabulary kind of established. And one thing we want to do is talk about not just sets and pitches as these kind of objects of study, but intervals themselves. And so I want to introduce to you the notion of interval class, and let's start with more definitions. Oops. Interval class. A class of intervals that might sound sort of obvious. Like pitch class, it refers to a group, a category. Like perfect fifths. All perfect fifths. All of them, not just one in particular. We represent interval class with a bracket on each side of it. And this should be familiar to you. One is a semitone. And there aren't that many, so let's go ahead and list them actually. One is a semitone. Two is 2 semitones. They're all numbers of semitones, but when we add them together, like what do we collectively refer to 2 semitones as? That would be a major second. Oops, not a period. 3, these also kind of line up with pitch class intervals for the at first. So 3 is a minor third. Again, the interval, not the note in the scale. 4, you might remember, is a major third. Again, the interval itself. 5 is, to be consistent, a perfect fourth. 6 is, oops, what am I doing? Yeah, that's fine. A tritone. And then let me explain a couple of these. The perfect fourth. So everything that I have said so far, like, that's not all of the intervals that there are, but those are all the intervals that there are that don't reproduce themselves under inversion. So the semitone is also represents the major seventh. The 2 is the major second, but it also represents the minor seventh. 3, not just a minor third, excuse me, but a major sixth, just like the inversions that you learned years ago. Major third is the same as a minor sixth. Again, by this I mean in terms of we will use these same numbers to represent both kinds of intervals because we'll always collapse things to be smaller than a tritone. I'll show you what I mean. So I will illustrate this for you, I promise. A perfect fourth and a perfect fifth are inversionally equivalent. So once again, we only use 5 to represent both of those things as intervals. And then the tritone, which is the same as itself under inversion already. So 6 is as big as any of them go. There are only 6. And so this is not the same as a set class, and then I'm not going to list a whole bunch of them side by side, but I can do this to show you an interval vector is a way of expressing how many of each interval class are, are within a set or set class. For example, let's look at the piece now. I've got some very small like versions of the score that I have taken as screenshots to make it a little bit more accessible for the Crucifixus. So I will like put this whole page so that you can look at it on canvas, but then I'll also put these like smaller, just like this part of the arm and this part of the arm, and then the whole vertical section. Okay, so as you can see, I've got my score excerpt here, and I'll have a blank one for you on canvas. And I've also got my handy set theory calculator right here, ready to go. So I want to use that just to double check things and for convenience sake, of course. So at the beginning, when we look at this much music, I want to focus on this like strand of, or this series of chords, or I think we can call them chords. You don't always necessarily need to use that term anymore, but this looks like a triad. There are 3 different notes. When I look at this, I'm noticing that there are grace notes that kind of correspond with a little slur to each one. And so I'm thinking, okay, I want to be able to figure out what set this is, set class or set or both. And I want to know which one this is, and then I can kind of make a little list of each one. And I do find it helpful sometimes when I'm doing that from scratch to do it with a piece of scratch paper on the side, just so that I can kind of jot things down. But in any case, for right now, I'll just mark it up on here. One thing that is the struggle with Crumb is reading his handwriting and deciphering these very, very low pitches in the piano. So here, let me just circle this for you. And we will note the pitches that we have in the set theory calculator as a way to kind of get started. So if you have to count ledger lines with him sometimes, so there's E, C, A, F, which I believe is what that is. So we've got an F, we've got an A with a flat next to it, and we've got a C natural. So a minor triad, and you might recognize the set class that it is belongs to 037, which actually accounts for major and minor triads in a set theory kind of notation. So let's have a look then at some of the properties of it. I think we did not actually talk about this in our previous week of set theory, that there's something that each set class has called a fort name for Allen fort, and that is just another way of identifying what that set is. Sometimes when you read articles about set theory, the author will just refer to set classes with their fort name, as in this is for Allen Fort. He has this big list of all the set classes that there are. This is a trichord in that it has 3 pitches in it, and this is number 11, if he just goes in order based on which intervals they have in them. So anyway, so notice that if we inverted it but did not transpose it, that you literally get 047, which is the same as the literal major triad. So that's kind of interesting too. Okay, so anyway, let's then 580 is the normal form of this particular set, and 037 is its prime form. We have not covered yet interval class vector, or IC vector, and I want to make sure that we do. So here, and we pull my notes back up. Sometimes it is called simply IC vector. Okay. All the intervals that there are within a set, and so they're sort of like different columns within an IC vector. So for set class 037, or let's start, we started with the pitches 5, 8, and 0, right? And so those together become set class 037, a minor triad. Let's just note that. Same as the minor triad. And let's see if we can find the interval class vector ourselves to kind of correspond with this. So this, each of these like places, the way that you would talk about in arithmetic way back when, corresponds to one of the intervals, one of the interval classes that we just listed. So semitone, whole step, minor third, major third, perfect fourth or perfect fifth, of course all their inversions apply, and tritone. So let's go back to the beginning of this set. This IC vector will be true for all sets that belong to this set class. So if 580 has it, then 047 will have the exact same interval vector. Okay, so anyway, going one column at a time, how many, or we could do it like this too, one category at a time, how many semitones are in this set? Well, if you look at it, there's no numbers that are right next to each other. From 0 to 3 is a third, from 3 to 7 is 4 semitones, which is a major third. So there are 0 semitones. How many major seconds or minor sevenths are there? And keep in mind that that would be interval class 2. Are there any times where you see interval class 2 in here? None of those numbers are separated by 2. They're all farther apart than that. So no major seconds or minor sevenths. Are there any instances of interval class 3, the minor third or major sixth? Again, we're looking for the number 3 in that case, either present literally like this one is, or like between two numbers. In this case, we have 1. There is interval class 3 between 0 and 3, right? So remember, these numbers represent pitches. These numbers and the numbers I'm putting here represent intervals. Okay, moving on. How many instances are there of a major third or minor sixth, which would both be represented by 4? Are there any places within this group of numbers where you see 4? And I don't mean in this case, there isn't literally a 4 in here somewhere. So from 0 to 3 is 3. From 3 to 7 is 4. So there's 1. From 7 back around to 0 is 5. And so no, that's not another instance of 4. There's just a 1. Kind of gave away the next column. How many perfect fourths or perfect fifths are there? You can also go back to the score and look at this, like, well, how many perfect fourths and fifths are there in this little chord? In this case, because we're looking at a simultaneity, a chord, and you can probably answer that question that way. But in any case, we know there's one instance of the number 5 between 7 and 0. 0 is equivalent to 12. So there's one instance of 5, but we already said this is 3 and this is 4, so just the 1. How many tritones are there? Finally, from 0 to 7 is 7. From 7 back around to 0 is 5. 0 to 3, 3 to 7. There are no tritones hiding within this set class somewhere. So that is how we arrive at this interval vector. This is the interval class vector for set class 0, 3, 7. Ta-da! We will do it with another one. But in any case, I want to also make sure we label this set right here. Oops, nope. Right here. Actually, I'll put it down on this plane here. 0, 3, 7. But that's what we've got going on right there. So let's look at this little set then. Let's look at this little set then and see if we have anything different or how they might be connected to each other. So here again, zoom in and look at those ledger lines in the bass clef, we've got, it looks like a B natural, D natural, and F sharp, meaning we have a minor triad there, which we already know is the same set class we were just dealing with, but let's look at it for a second. That we have, oops, I meant to hit submit, and instead I hit reset. Okay, so here's another 037. Both of these are the 037. And just to review how transposition works from last time, we want to figure out how these two set classes are related. And I want to be these two sets are related. So we had 5, 8, 0. And now we have, what did I say this one was? Oh, there it is. 11, 2, 6. Take a look at those and tell me if you could figure out, like, what is the mathematical distance between each of them? Like, what do you have to add to the top row to get the bottom row? It's just simple arithmetic, nothing too fantastical at this point. So what is the difference between 5 and 11? Or like, what is that number? What do you have to add to 5 to get 11? 6. I'm being very literal here. What do you have to add from 8 to get to 2? And you might be thinking like, well, from 2 to 8 is 6, but remember we're going to go up each time since that's where we started. So from 8, if you add 6, you get 14. Remember your mod 12 pitch space rule, that 14 in mod 12 pitch space is actually 2. Oops. In which case, this one is also 6. Last one of those. 0 to 6. You might be like, well, that's obviously 6 because 6 plus 0 is 6. 0 is also in mod 12. It is equivalent to 12. So the difference between 6 and 12 is 6. I hope I'm not like hypnotizing you the way I'm saying all these numbers. This might be a video that you want to slow down the speed, or you might want to just, give yourself a second chance to listen to it. In any case, these are unordered sets, right? We've got 5, 8, 0, and set E2, 6 are related by, we just figured out their transposition interval. They are related by T6, like that. Which is great. So now we know these two instances of 037 are related by T6. And you might recall that I like to kind of make a little like, a little thing like this to show that. And then I like to write T6 and in between them somewhere to show their relationship. So the right and the left hands are T6 related, at least on this beat. And the best thing to do to be very thorough would be to go through each of these and each of these to make sure that they're all 037 and that they're all related by T6. But spoiler alert, I'm just going to tell you right now that I know that they are because I have analyzed this before. So just in the interest of saving time, I'm going to let that lie for now. I want to look at another interesting thing about this this segment of music, and in the process we can practice another interval vector to just see a different version. Okay, so as I said, spoiler alert, we know that each of these is 037. Now you'll notice that as triads, they're inverted in what we would call Boba, that's enough. They're inverted in what we would call the sense of like a triad. They're inverted in the sense that they might be in a first inversion of a triad or a second inversion triad, but they're not inverted in what we would consider pitch class space. So we're not going to worry about, we're going to call all of them 037 here. There may be an awkward cut coming up if my dog starts to bark. They're thinking about it. Okay, so as I said, each of these are 037, each of these are 037. They're always related by T6. So one thing I want to say about the Crucifixus is that the interval class of 6, if a lot of things are related by T6, then we can certainly say like T6 is an important operation in this piece. But also, depending on how it manifests, we might say that 6 as an interval class is significant in this movement. Like structurally significant. It does something, it has something to do with the narrative, which we can come back to. So in any case, we've looked at it very vertically oriented so far, and I want to make sure that we look at what's going on in the pitches kind of happening on the top of each of the triads as the series ascends. So here we've got, let's just sort of take a little inventory. I'm making a decision, and I want to show you this because this is a subjective decision. Like, this is a really important aspect of set theory. It is not just like putting a piece into a computer and then having it spit out an analysis. Like, your job as an analyst is still very subjective at this point. So one of the decisions I'm making is to privilege the idea of 3-note sets or trichords in this piece as a whole, because I think that they are really important to its structure. We have these 3-note segments here and here. Notice that here's another one, and we'll talk about it. And there are other ones throughout the piece. So I'm going to focus on these 3 notes at a time, even though they're not grouped like that. There's 1, 2, 3, 4, 5, 6, 7 total, which means we don't have an even number dividing by 3 or an even number in general. That's fine. We're still going to focus on 3 at a time. 7 is also a number that for Crumb has in the past had some like numerological significance as a symbol, usually of something good, not of like something evil, but anyway. So let's look at this. Let's just make an inventory of the notes that there are to start with. So let's just take an inventory of the notes that there are to start with. We've got, again, we're just focusing on the top note of each of the right-hand triads. We've got C, we've got E, we've got F sharp, we've got A, C sharp, E flat, and F sharp. Let's put those into some numbers. And here's what we'll do to make this into 3-note segments is we'll look at these 3, and they'll overlap with each other then starting there, and finally the last 3 together. So you can see how notating it as letters is kind of cumbersome, but sometimes I still do it as a place to start, just to like jot something down and then kind of work through it with numbers. So 0, 4, 6, say them along with me if you're ready, 9, 1, 3, and 6 again. So we'll take them in 3 groups at a time, groups of 3 at a time. So 0, 4, 6, and then we will look at 6, 9, 1, and then we will look at 1, 3, 6. Right there. Okay, so let's do some things with those sets to figure out what's going on. Total. And just to be clear, because sometimes like I'll jot this down and then come back to the paper a little while longer and I'm like, or a little while later and I'm like, I have no idea what these numbers are about. So these are the top voice of the ascending triad strain in the left arm of the Crucifixus. Okay, so back to the set theory calculator again, because life is short. We've got 0, we've got 4, and we've got 6. Let's put that into the calculator and see what its prime form is. It is already in its normal form, and its prime form is 0, 2, 6. So that's the set class that it belongs to. Okay. Then we've got 6, 9, and 1. If we submit that, that's our familiar friend, 037. So we've actually heard that set a couple of times already. Then, if we do the last one, we've got 1, 3, and 6. That set class works out to be 0, 2, 5. I want to do interval. So let's do interval vectors for a couple of these. Let's do an interval vector for 0, 2, 6. See if we can come up with the same one that it has there. How many semitones are there? From looking at this, there's no instance where like 1 is the difference between any of these numbers. So there are 0 semitones. How many instances of interval class 2 are there? Well, there's definitely one between 0 and 2. Between 2 and 6 is 4 though, so that's not 1. From 6 to 0 or 0 to 6, nope. So 1 instance of set class, or of interval class 2. How many examples are there of interval class, go all the way back up here, 3, the minor third, or major sixth? Let's see. Again, we're focusing on this one here. There's no literal 3s in here. From 0 to 2 is 2, from 2 to 6 is 4, 0 to 6 is 6, and 6 to 0 is also 6, so there are 0 instances of interval class 3. How many instances are there of interval class 4? Well, if you look here, from 0 to 2, we already know is 2, from 2 to 6 is 4, and I believe that's the only one. Then, how many instances are there of interval class 5, which again is that perfect fourth or perfect fifth? Are there any 5s that you could get out of combinations of these numbers, or the distances between them? Not there. No 5s. How many instances are there of interval class 6, however? 2, because we're going to go from 0 to 6, and from 6 back around to 0, and those are each 6. So we'll call that interval class 2. So we'll call that 2 instances of interval class 6. Let's check and see if I did that correctly. 0, 4, 6. Oh no! I got ahead of myself. There's only the one from 0 to 6. That's why you should use your interval class checker on the set theory calculator. I'm glad I had you see me make that mistake though, because I don't know. Set theory can be intimidating. I don't do it perfectly all the time. I want you to know that. So, in any case, there is only one 0, 6 relationship there. We don't go backwards. So, from 0 to 6 is 6. We note that here. Notice the symmetry in that interval class vector. So this has some properties already, some special properties because of the symmetry here. Let's do the same thing for 0, 2, 5. We didn't do that interval class vector yet. So this is the IC vector for 0, 2, 6. Let's do it for 0, 2, 5. No semitones. One major second for sure from 0 to 2. But no others. Oops. Whoa. Sorry. Is there a minor third anywhere or an instance of 3? Actually, yes. Between 2 and 5 is 3. Dang. Really trying not to confuse you, I promise. Is there an instance of a major third of interval class 4? There are no 4s that you can get by combining these numbers, so no. How about interval class 5? Well, yes, there's definitely one from 0 to 5. And any others? I don't think so. For one thing, we're doing this with very small sets. We could have like a 9-note set that would have tons of intervals in it, and it would have probably more than one thing in each category. We'll do a longer one later so you can see what that would look like. And again, looking at this set class 0, 2, 5 here, are there any instances of a tritone anywhere in that set? I don't think so. So no tritones. Let's check this one too. We had 1, 3, and 6. Again, we're only using the prime form to figure out the interval class vectors, not the normal form or the unordered set. I mean, we could do that, I suppose, but I prefer to put it in prime form to figure this out. In any case, you can look over here. Here's the interval class vector. Oh, does it match the one we just found? 0, 1, 1, 0, 1, 0. Yep. So that was correct. So they're each a little different there. We already did the one for 0, 3, 7 above, and that is still the case. I wanted to point out to you that, so that means that here we have a couple different sets. I'm going to change the color so that it's like, I don't know, differently visible for each one. Boop. Let's change it back to blue. Oh no, I thought it would let me do that and it will not. Okay, great. In any case, we've got, for these top note set classes, we said the first one was, let's go back here, 0, 2, 6. The second one is 0, 3, 7, the triad. And then this last one we said is 0, 2, 5. So a couple of different sets there. Not going to be related to each other by transposition because they are 3 unique set classes. So that's all I'm going to talk about in this video, and in the next video I'll have some more to say about this particular piece. We will talk about symmetry as a concept and look at the vertical section, which I will have rotated for you in the example. Because you can see that just physically, symmetry is an important quality in this piece, and we can talk about some of the symbolism as well. So I will see you in the next video. Bye for now.